Hi, Savannah. I'm going to go over the proofs that are on the review here with you. I don't think I've got your other ones. The pictures didn't come through for some reason, but I'll go ahead and show you how to do these. So let me get rid of that. Okay. So we want to prove that K is the midpoint right here of NL of this line here. And what I've told the classes before is that here's our two givens. The proofs on this test there's three kinds. One is you just prove prove congruent triangles. So if that says prove, triangle ABC is congruent to triangle DEF, then that's the easy kind. You just show me the parts, and that's it. The second kind is prove a congruent pair, where if the proof statement is something like prove angle A is congruent to angle B, then that's the second kind, and that's where you would find the triangles congruent first, and then you use the corresponding parts statement to go one step past that to prove, and you just choose a piece of the triangle, like some angles or maybe a side or something like that. And then the third kind is two steps past it. If it's not proving triangles or not proving a congruent pair like this, K is the midpoint, then it's going to be two steps. Why is my pen not working anymore? Okay. Oh, there it goes. Okay. It's going to be two steps past the congruent triangles. And I'll show you that right here with this. So let me just get a bigger eraser real quick. All right, let me get rid of all of this. And we'll go right into it. Okay. So here's my two givens. I'm going to go ahead and mark them. Let me use a different color. So angle N is congruent to angle L. And then JK is congruent to MK. So that's not enough pieces yet. I need three congruent pairs to prove triangles. And I've got two. I've got this angle and these sides, and I'm going to use these angles right here, these vertical angles, as part of it. So I'll make a new box and say that angle JKN is congruent to angle LKM because they are vertical angles. So here I've got an angle and a side and another angle. Angle, side. Because this side is not the included side. It's not in between the two angles here. This would be the included side because it's between this angle and this angle. But that's not what we have right now. So this is going to be angle, side. And I can write that in a box. So I'll say that triangle JKN is congruent to triangle. Well, if I call this one JKN, then I need to call the other one MLK, because I start with the angle that's not marked. That's the first letter, and then I go to this. I called it wrong, didn't I? Then I go to the middle one. So this needs to be MKL. We need to make sure that the parts correspond. So I go from the unmarked angle to the angle with two arc marks, and then over to the angle with the one arc mark. Okay, so there's that. And that was angle, side. So angle, side implies congruent triangles. And there's an arrow there, and an arrow there, and an arrow there. Okay, so next, now that's not what we're proving, but it helps us. We're almost there. We want to prove that K is the midpoint. So now I need to think, what do I need to show before I can show that K is the midpoint of this line? Well, if you remember your implied statements, I know that a midpoint implies two congruent collinear segments. So I'm going to use that the other way around. I'm going to show that because my triangles are already congruent, then all the parts are congruent. So I can say that segment NK is congruent to segment LK because congruent triangles imply congruent corresponding parts. And then that leads me to the proof statement that K is the midpoint of NL. And I use the one I just mentioned, but the other way around. Two congruent collinear segments imply a midpoint. And that's it. So there's the first one. Let's take a look at the next one. I want to prove, I want to prove a pair, a congruent pair. So this is just going to be one step past the congruent triangle. So let's see what we have. We have AB and CB are congruent. We've got an angle bisector. I'll get to that in a minute. And then angle A congruent to angle C. So here is an angle and here is a side. Now, an angle bisector, let's see, DB. So this segment here bisects ABC. So this angle here. Reset. That an angle bisector gives us, I'll write that first. Angle bisector implies that we've got two congruent adjacent angles. And that's these two that I just marked, ABD and CBD. So I'll put that down. Angle ABD is congruent to angle CBD. And now that's another pair of angles. So now I've got angle, side, angle. And this side is the included side because it's between this angle and this angle. So this is included. So I will use angle, side, angle. So now I prove that triangle, let's see, I'll call it ABD, is congruent to, just give myself some more room, triangle. Well, if I call this one ABD, then I need to go in the same order over here, CBD. And I used angle, side, angle, and that proves that I've got congruent triangles. And now I need to show that this segment here, AD, is congruent to this segment here. And because that's part of these two triangles, then I just pick that and use it. It's going to be that same one, congruent triangles imply congruent corresponding parts. And it's the proof statement there, AD congruent to DC. So here's a couple tips. The first part, the easy ones are going to prove congruent triangles. Then the next one, if you're just like this, if you're proving congruent pieces, then the next one, this is always going to be the next step. Always is going to be the step after congruent triangles. You're going to have congruent triangles imply congruent corresponding parts. It's spelled parts. This is always going to be the next one if you have to go a step after. And even if you have to go 2 steps after, that's always going to be the second one. And then you'll just need to see what you need to prove to get to that. So let me do the next one. Let's see. A is the midpoint of TY. So we're not proving triangles, and we're not proving congruent pair. So this is going to be 2 steps afterwards. So let's take a look at what we got. Let's use purple this time. Okay, I've got ET is parallel to HY, and then ET is also congruent to HY. So there I've got some congruent sides and they're parallel. Now I can see that these are vertical angles, so I'm going to say that, angle angle TAE is congruent to angle HAY. And those are vertical angles. So now I've got an angle, a pair of angles, and a pair of sides. So I need something else. But these parallel lines will give me those. Parallel lines always give you angles, congruent angles. And in these proofs, it's pretty much always going to be alternate interior angles. So I'm going to use this angle here and this angle here. So that's what's going to happen with those two. Hold on, I think my battery's about to run out. How much time do I have left? 7% remaining. 17 minutes. Okay, I should be finished in 17 minutes. Okay, stop. Go away. All right. So vertical angles. Yeah, so the parallel lines are going to give me these alternate interior angles. So from there, I can show that I just call it angle T is congruent to angle Y. I can use one letter because there's just one angle at those letters. So that was parallel lines imply congruent alternate interior angles. So there's another pair of angles. So now I have angle, angle, side, because that side is not included. It's not in between, so it's not the included side. Okay, so I've got angle, angle, side. So now I can say that triangle TAE is congruent to triangle. Let's see, I went TAE, so I need to go YAH. And I got an arrow from each of the pieces into that. And I used angle, angle, side implies congruent triangles. Then I need to prove a midpoint, just like we did in number one. So I need to prove that A is a midpoint of TY, this right here. So let me see. Oh, I need to show that this is congruent to that. So that gives me TA is congruent to YA, those segments, because those are parts of the triangles that I just proved that were congruent. So congruent corresponding parts. Always the one after congruent triangles. And then the last box is going to be the proof statement. A is the midpoint of TY. And that was two congruent collinear segments imply a midpoint. Okay, let's do the last one real quick, and that should get you going. So let's see, prove DG. This, I want to prove that those two are parallel. So that's going to be two steps afterward because it's not a congruent pair and it's not congruent triangle. So it's going to be two steps after. I see that this is a shared side. So I can say that DF is congruent to DF. And that's the reflexive property of congruency. And that's a side. E and G are congruent. So these two angles are congruent. That's an angle. Now I've got parallel lines again. DE, the top one is parallel to the bottom one. That makes DF, this line in the middle, that makes that a transversal. So here are some alternate interior angle. Oh, not that one. This one. These are alternate interior. So EDF right here. This is going to be, let me zoom in a little bit. Now I lost my pen. Okay, here we go. Angle EDF congruent to angle GFD. That's parallel lines imply congruent alternate interior angles. And now I've got Angle, angle, side. Let's see, is that angle, angle, side, or is it angle, side, angle? I got angle, angle, and then the side. Yeah. This side is not included between this angle and this angle, so it's angle, angle, side. So from here, I'll say triangle DEF congruent to triangle. Let's see, if I went DEF, then it would be GFD. And that's angle, angle, side. Implies congruent triangles. The next box after is always going to have this statement. Congruent triangles imply congruent corresponding parts. So what parts will show me that that these sides are parallel? Well, the other angles, these right here, let me use a different color so it's easier to see. This is getting a little bit messy. This angle here and this angle here are congruent because of the triangles. So I'll put that in there. Angle GDF congruent to angle EFD. And then that gives us, those are alternate interior angles, just like the other ones we had. So congruent alternate interior angles imply parallel lines. So that gives us the proof statement. DG is parallel to FE. Notice that we use the same thing here, right? Just the other way around. So there's your last hint. Whenever you see parallel lines, look for those alternate interior angles. Whether it was given to you, you're going to use them, or if that's what you're trying to prove, you're going to use them. So there's some hints, and I think that'll help you get past those a little bit better. So there you go. Let me know how you did on those.